where is that rider located? Number two is what is the rider's rating?
Hmm.
Number three is
Hi, everyone. It's Jay from Interview Query, and today I am joined with Chinmaya for our mock interview kind of series on YouTube. And Chinmaya is newly PM at Microsoft. He joined from Smith's College in the AI program and is now doing data science product management work for Microsoft coming up next week, I believe. And so, Chinmaya, I'd love to just first kind of like get a sense of your background and tell the audience kind of how you got into data science and kind of like why you were interested in it.
cool. Yeah, thanks, Jay. Thanks for having me. I kind of stumbled on your interview query on when I was studying for my interviews at Microsoft, so
Yes,
it's come full
perfect.
circle. So it's great to look back and say, oh wow, like I've learned a lot enough to be here. So thanks for having me. My background, I did my undergrad at U of T in University of Toronto. For those who are not familiar with it, in business administration, uh, had kind of data on my mind. Never left me. I I was always like curious about it, how it worked, where it could be used, and how we could make better decisions with it.
Hmm.
Which led me down a very winding path, I would say. First into brand management, then product management and product marketing, and then finally kind of landed up at Queen's University at the Smith School of Business and the AI program, where I've been trying to take all the things that I've learned about data, about IT, about systems, about marketing and business, and put them all together to make intelligent systems. Because that was the opportunity that I saw, and I was hoping to land a AI or ML based product management role, which ended up happening. So really happy about the outcome there. Overall, I'm just really excited about what this field has to offer. I think we've barely begun to tap into what's possible.
Hmm.
Um, and as important as the technical skills are, I've learned that there's a lot of business context that data scientists need to think about. And many times that a model just is just scratching the surface. The real solution is often how does it solve a problem for the end users? So that's kind of where I want to keep growing and take my skills.
Awesome. Yeah. And I think that is definitely encapsulated more and more also in the interview process as you see more interviews kind of geared towards how you can think about the nuances within each problem. And you're not just, building a, model to code at your laptop and then deploy and just, forget about it sort of a thing. And so segueing into this actual mock interview. So today I'd love to talk about a problem that is asked at Uber. And so it's modeling based. And so the question at hand is you're tasked with building a model to predict if a driver on Uber will accept a ride request or not. And so how would you go about building this model? And what kind of features would you use? What model would you select? And so on.
Cool. So Uber wants, just to clarify the question, so Uber wants to know whether a person will accept a ride or not, and we want to build a model to predict that.
Yes.
Cool. Okay. Just give me 2 minutes. I'm gonna do something that I like doing during interviews because I think it's like a neat trick.
Yes.
Uh, so let me just start sharing my iPad screen. I find that this is like a virtual whiteboard in COVID times that I would normally have in a real interview. Okay, so we're looking at we're looking specifically at the driver angle, not at the rider angle, right?
Yep. And so if you imagine how Uber works,
Yeah.
we have the drivers and the riders make requests to
Yep.
get rides, and then I guess Uber sends out general requests to each driver within a certain area or radius to see if they'd
Right.
accept the request.
So the driver gets a request, and do you know what the driver is shown or an Uber driver is shown about a rider and the kind of information that they're given to make that split second decision?
Let's say that as the company, this is a feature that you can customize, right? And so we can show a lot more information, or we can show almost no information. I think uh, depending upon also there's like a monetary, like this is how much it might you'll get from it, and I think that is something that they also use to incentivize riders to drivers to accept the request or not.
Okay, interesting. So the way that I'm kind of like thinking through this is that there's like three buckets of information that's shown to a driver about a rider.
Okay.
One is like there's a lot of info. The second one is there's some info, and the third is lots of info.
Yep. Okay.
Okay. So the reason that I'm kind of doing this, maybe I don't know what the circle is, but anyway, we'll ignore it for now. So what I'm trying to do here is I'm trying to just get an understanding of the Uber business and the kind of the user experience that a driver has with a rider. So I'm asking these kind of questions to determine whether, because I'm kind of thinking through this as the driver has to make a split-second decision, especially when they're when they're either completing an existing trip or they're on a trip and about to end. That's kind of like the 2 points. So maybe if I like model this out a little bit more, the
Yep.
driver essentially has either they choose to new. So I'm going to say like driver new trip. So they either decide at the end of their current ride. Oops, current ride, or middle of their existing one, or like late in the game.
Okay.
So given that, I think what's usually as I'm kind of like brainstorming, if they're shown the distance, so that would actually be the first one to like to say, okay, well, distance to next rider.
Mm-hmm.
Then of course, if you show that and if it's small, then they're likely to accept. So that would be one of the features that I would kind of start thinking about as I'm starting this modeling exercise. So before, I mean, I know what we're trying to do is get into the model, but the first step that I'm trying to understand is the user journey. The second one that I want to do is actually the exploratory data analysis piece to
Okay.
actually understand the relationships between data points that Uber may have today about their driver
Mm-hmm.
or their rider and what the relationships between those features are. So
Okay.
there's distance, and then there's also, so there's actually two kind of distance data points. We have distance to next rider from the driver's current position, and then you would have distance, uh, let's say trip, um, trip distance. That's kind of like the two main areas that I'm thinking. How does that sound? Like, am I missing anything on the distance piece that you think I should be thinking about?
Yeah, so I think that's kind of a great way to frame it because there are kind of like trip characteristics, right? And these
Right.
are the distance, trip distance, and then there can be other things such as the general. I think we mentioned this before, like the price that you get from the trip. Um, like how long this trip might take. I guess that's a function of the distance, and then just kind of like what time you're taking this trip right now. If it's like
Mm-hmm.
12 a.m. versus like I don't know 3 p.m. or something at rush hour, and so these are all kind of like characteristics of this one entity. And then there's also, I think, this multi-sided marketplace. We have like the driver side, and then also potentially the user information that you put at the top as well.
Right, right. Yeah, because I think the multi-sided marketplace brings up something that I didn't think about yet, which was this idea of, and I don't know if Uber does this today, but picking up Uber Eats orders on the way if they're taking a driver or they're just ending a trip maybe.
Yeah, that is true. We could probably scope that down to
Right.
just the Uber driver marketplace. Yeah.
Okay. So no to that. Cool. So the two main buckets I think that you highlighted, which we just kind of like briefly discussed, are, so if I kind of like think about characteristics from high level umbrella and then break that down into, okay, so there's kind of trip, there's rider, there's, oh yeah, of course, there's driver as well.
Mm-hmm.
So the driver itself, themselves, or him or herself will have their own kind of propensity to accept rides or not accept rides based on certain time of day or number of rides that they've done in their shift maybe, or even like how much money they've made throughout the entire week or whatever time span we choose to look at.
Yep.
So if this driver is coming off like an 8-hour shift, they're not going to do another ride.
Yep. Exactly.
Yeah. So there's trip, rider, driver, and oh, of course, how could we forget traffic?
Traffic.
So traffic is I feel like that's how most decisions will be made in large cities. It's like, is it like 5 p.m.? So if it's 5 p.m., it's like, I'm not doing any, that's it for me.
Yeah.
And especially like traffic would, I think traffic is kind of related, but not directly. I think there's like some indirect relationship between traffic and special events. This is of course like pre-COVID times.
Mm-hmm.
And special events. So I'm thinking surge pricing during, let's say, like your favorite basketball game or hockey game or even like whatever sporting event or whatever event. It could be anything.
Yep.
So traffic is likely to spike up, but at the same time, surge is going to go up. So even if there's a special event at like, that's ending at 5 p.m., even though there's a lot of traffic, people might be on the road because there's a bunch of people that are requesting rides. The other thing, yep.
Characteristics of like a trip potentially, like I guess the trip that you take, the traffic would almost be like factored into it, kind of special events as well. So either maybe not at this kind of dimensionality, but like in general, I think at some point they could all roll up under kind of like a trip in a sense, and because yeah, I think the rider has its own information. The driver has its own kind of information about themselves. They have ratings. Riders have ratings, and then a trip could then just have like potentially its own rating too, right? From like 1 to 10 of how like great this trip is versus like how horrible this trip might actually be.
Mm-hmm. Mm-hmm. Yeah, I think that's actually a good point. I'm gonna put it down, but it's something that I'd like to visit later on.
Okay.
Because if we start thinking about quality of trip, then that itself is honestly a model to predict, to like regress it or classify a trip based on like certain factors. We would actually need to do a deeper dive into that.
Yep. Okay.
But another big thing is actually like, and this is something that I don't think many people would think about, but it's vehicle condition. So, or actually not even vehicle condition, I'm going to say vehicle itself. And I'll like kind of explain a little bit more. So one of the use cases that I'm thinking about is I'm kind of out like, pre-COVID. I've had a decent day at work. I have some energy left over and I want to pick up a few riders. But likely what's going to happen is I'm going to do this like closer to 10, no, sorry, either closer to like 10 when people decide to head out, and I'll pick them up to drop them off at the club or whatever they're going, or whatever venue that they want to attend. And then most likely I'm going to be out on the road either around midnight or 1 a.m. again. But but the number of riders or number of rides is actually linked to the type of car that I have. So I couldn't really pick up, a party
Mm-hmm.
if I only have a car, or if I only have Cooper. I can only pick up 2 or 3 people. But if the car that I have is in the garage, or like my van, my extra van, is in the garage, then I can't use that. That's number one. Number two is I'm unlikely to, if I have a second car, I'm unlikely to actually use the van during regular drop-offs when it's like one driver or two rider interactions.
Okay.
Um, I'm likely to use my regular car for that kind of. So what I'm saying is that the vehicle type and the vehicle condition would affect the driver's ability to accept certain trips.
Gotcha. Okay.
Yeah, may. I'm not deterministic. Everything's probabilistic at this point. Um, I think that's a good like starting point. What do you think? Is there
Yeah.
any other characteristic that you would want
No, I think
that you
those
think I missed?
are good. I think these entities are kind of like good features. I think we have like the main ones in the center with the
Yeah,
trip, rider, driver, and then we have these kind of special conditions that matter a lot towards the
yeah,
actual degree of the model.
yeah.
And I think those are good because they're pointed out.
Cool. So once I get an understanding of these things, and of course I can like spend ages going into each of these characteristics.
Hmm.
The there's like within vehicle, there's some items that I would think about like vehicle type, number of passengers the vehicle can hold, the last time it was repaired, maybe the vehicle's overall condition itself. Meaning, yeah, I don't know if Uber does this right now, but I don't know if it usually asks drivers at the point of signing up. I think I remember when I was a driver at one point that they asked me, how old is your vehicle, and when has it last been serviced?
Hmm.
So picking up or asking drivers to give more updates on a vehicle's condition may be beneficial to predict the outcome for something like this.
Gotcha.
Around trip, I would look at, there's like this, again, this giant umbrella of quality of trip, but within that, there's items like time of day, trip distance, the potential revenue that the driver can afford to earn from this trip. Oh, uh, keep getting this doesn't happen normally, but I keep getting, yeah. So you have a lot of different items about a trip. Then you have riders. So from the rider angle, the first one is where is that rider located. Number two is what is the rider's rating.
Hmm.
Number three is how many riders is it, because it's not just one request. And as we've talked about, the vehicle type will affect whether that Uber driver is able to pick up that passenger or not.
Yep.
Um, then the other, like on the rider side, I would again look at uh, time time of day, and also like neighborhood. So many times I think rider drivers may be hesitant to pick up certain riders based on where they are, and it's unconscious. I don't think it's like, sometimes it is conscious, but I'm going to chalk it up to unconscious bias, where
Mhm.
if there's like a sketchy neighborhood, or if it's like deep into entertainment district at two or three in the morning, that rider is likely to be out of it,
Yeah.
or might cause unneeded distress to the driver, so they may like sway away from that.
Yep.
On the driver side, the most obvious is like, how often does this driver actually accept rider requests?
Okay.
Very simply.
Yep.
The second one would be, what is the driver's rating? Because and also, is there a link between rider quality and driver quality? And I'd be kind of curious to see if Uber's already kind of figured something out there, where they suggest certain high quality riders just to specific high quality drivers, and whether that rating itself has a factor in who's recommended to the driver. Because that may that may have a very highly correlated effect on the driver being saying yes or saying no, because of like kind of the previous like mental history that they've built with Uber, or the relationship that they have.
Yep.
Traffic, so time of day again. So time of day kind of comes into both the trip and the traffic aspect that we just talked about. That's
Mhm.
why we have the line. Um, the other thing is sometimes, and I'd be kind of curious to see what this looks like, but right now, I think Uber connects to Google Maps API to actually select the route,
Yep.
but traffic patterns are usually best when they're crowdsourced, like from Waze. So I'd be curious to see if there was an uptick on the driver's ability or driver's like propensity to accept rides in high traffic times if we switch to Waze. That'd be like a fun experiment to kind of understand. But I know it's away from the central problem.
Okay.
The other thing that I would want to look at is traffic based on rider pickup and drop off locations. Sometimes traffic is random, so it's not gonna it's random, but it's also sort of predictable. You're not gonna take large streets during rush hour. You
Yep.
could take side streets and still get to the place that you want to get to if there's a side route access or side route path. So that would be again like, is there an alternate route based on the driver's location, the rider's location, and the rider's drop-off point?
Gotcha.
And if yes, during a traffic time, that may actually, and if we show that to the driver when they're picking whether to accept a rider or not, then it may influence the decision to say yes or no.
Hmm.
So just that's an angle. Special events, of course, this is like very. It could be very categorical, like special event 1, 2, 3, 4, and then there could be kind of uh, attributes associated with each of those categories. And I'm guessing we can bring a lot of those attributes into this model that we want to build, or into the initial sample data set that we want to create.
Okay.
Um, does that all make sense? Any questions? I know I said a lot of different things about these characteristics piece.
I think that makes sense. I think one problem that we might have to think about is, let's say that we have general like missing data for some of these aspects, right? Let's say new riders, new drivers, we don't have any
Yeah.
information on, right? So is there any way that we can correct for that, given that it's probably like, a big aspect of our model is just the historical acceptance rate from drivers in the past, or kind of like data on the rider itself?
Yeah. Yeah. So essentially what you're saying is, how do we deal with null values, right?
Yeah.
Yeah. Okay. So yeah, there's a couple of ways. I mean, I'm guessing we've done, like, Uber has probably done some form of like clustering or unsupervised learning on this data set. So they
Uh-huh.
might have a intuition about what a driver's profile looks like based on like age or the information that they provide during sign up.
Yeah.
We could probably pull like the median or the mean from those profiles and populate them into these null values at the beginning, just
Yeah.
to get like a feel. And these would of course come from the actual clusters that have already been built. And I'm assuming this. If we don't have that and that assumption is not valid, then I think probably giving them, as I said, like a mean value, not from a cluster, but from the given like column or feature, would be good enough. But you would need to know that that's those like new sets of users would be part of another cohort, and that we could potentially, if we don't have data from before, we could start doing a much more closer detailed cohort analysis on this new group of drivers um, that may have joined uh, like even now. So you could take a look at a cohort of pre-COVID drivers, and you could take a look at post-COVID drivers or intra-COVID drivers. And
Hmm.
intra-COVID drivers are much more likely to behave very differently than any of the pre-COVID drivers were.
Yeah.
Most more likely they're going to take special events. This is great because this links back to my earlier point. Special events like a pandemic have a direct effect on whether a driver is going to accept a rider, because if has the rider worn a mask in the past? Is the rider wearing a mask now? What is their safety rating? Like, have they kind of abided by some of the principles or the guidelines that the government has set out? Things
Yep.
of that nature. And I don't know if Uber is collecting data on that now, but this exercise would probably start that questioning if it hasn't already.
Gotcha. Cool. No, I think that's a great point. I think on that note as well, I think for many drivers, thinking about their like acquisition to like Uber is also kind of important because a lot of the times I know in the past they've done incentive programs based on how many drives that they do or rides that they do, and I think like on that point that kind of may help with like the cold start problem as well in terms of being able to give them extra data on this, you know, driver has to do 5 rides by the end of today, and so maybe be more incentivized to finish the ride at that point.
Makes sense.
Yeah, and so for the next part, so we have all these features, we have this data. How do we start building the model? What kind of like process goes in terms of like the model selection uh, portion of this, and then how do we then evaluate our model?
Yeah, sure. I mean, the way that the question is worded, it's quite obviously like a classification problem where you want to say good drive, like, yeah, accept. The question would be accept or not accept.
Yep.
So then you could put people into one of those two buckets. But of course, the more nuanced version would be like a more multi-class model, multi-class system where you have like very likely to accept to not at all likely to accept, and you have like a spectrum of classes in the middle. I would stay away from regressive or regression because I wonder what the score or the Y value would be. You have essentially a lot of features, but I mean, you could pull out a probability of accepting from a logistic regression based on like the class that they select. So like we can set an arbitrary threshold as well, and that the classes would actually kind of determine that.
Yep.
Where let's say 70, the obvious number is 50, but likely it's going to be like, let's say if they're above 70% probable, then they're likely to accept the ride, and if they're less than 70, well, they're not going to. And then you could break it up. But I think a logistic regression would be honestly the best first start. We're not as, I'm guessing the model's performance matters more in this scenario than the feature understanding.
Okay.
And here's why. The logistic regression would kind of kill those two birds with one stone. You would do the exploratory data analysis first, then you would throw the sample data set in and into a logistic regression, tune it, but then you could always look back and see what features drove probability of accepting or not accepting the most. So that would give you a like a direct understanding of your data, but then an indirect understanding by digging back into the model's results. So log would be the first, and then I would start playing around with, once I have like I'm guessing this initial data set is going to have like 50 to 70 features. We want to trim that down as fast as possible because it's going to take too long otherwise. And likely there's going to be data leakage and high like collinearity, not collinearity, but like highly correlated features.
Yep.
So once we get that down, another like cool model to check out would be decision trees, because decision trees kind of open up this other like broad swath of models and ensemble methods that we could kind of try out, like XGBoost, AdaBoost, even like random forest as well. But of course, those then when you start going to those like less explainable things, it becomes harder to know which features are kind of contributing to the score. So that's where I would start on the roadmap wise. Understand the data a little bit more with the model that I'm trying to build the model, tune it, and then start playing around with ensembles. Because ensembles is where you can actually really increase the model's ability to classify a driver as negative, as likely to accept or not likely to accept.
Cool.
One other angle, and I think this is like often missed in more academic settings, is how are we going to get labeled data? And I'd be kind of curious to see if if there's already a score that Uber has, or probabilistic score that Uber has about their driver and their willingness to accept, that they maybe already built, that we can use as ground truth value. But essentially, that would be a big problem to solve before we got to the modeling.
Okay. Yeah, so let's say, the kind of like the feature and how it works is that you're driving and then you get a ride request, right? And then you can accept it or not accept it, right? And
Yeah.
so many times in that scenario, we would have, people that have accepted it, people that have said like no, or people that just like it basically just timed out, right, from inaction essentially. And
Mm-hmm.
so we could assume that's no. Potentially, within their system, someone else might have accepted it when they also wanted to accept it, right? And so, I mean, given this kind of like labeled data set, does that kind of inform more of what kind of model would be built or how we might evaluate the model?
So, okay, just gonna kind of conceptualize this a little bit.
Mm-hmm.
So what you're saying is a driver, we have history about a driver accepting or not accepting ride requests.
Yeah. So let's say we have this data set of
Yep.
ride request data.
Yep.
We have the feature and how it's used with like the rider, and then we have this like existing, I guess, kind of method that was or feature rollout that basically showed this scenario that you're building out,
Mm-hmm.
where basically, a driver could either get a request and then within a certain amount of time, if they haven't done anything, then maybe the next driver gets a request.
Yeah, interesting. Okay. So so essentially I'm kind of thinking, so you would have uh I guess, would you have like a list, or I guess a count of acceptances for each driver, right? And drivers.
Mm-hmm.
And then let's just say like 5, and then this is like 20, if you will. Hmm. Yeah, I mean, the acceptances alone wouldn't really give you the ground truth that I mean, it wouldn't really give me the ground truth that I'm looking for. I would probably need more details into this, such as like number of trips taken, or like completed. Um, I guess what I'm saying is looking at acceptances without any context might be might not give us like the correct label.
Yep.
Does that make sense?
Yep. Because potentially, if driver N has 20 and driver
Mm-hmm.
1 has 1, then those get
Mm-hmm.
blended together as the same data set, correct?
Exactly.
And so
And
potentially,
just because someone has a lot of trips doesn't mean that they're more likely to accept a rider. They actually might be less likely to accept a rider.
mm-hmm.
And no, like you can't. I wouldn't look at any one feature on its own about a driver,
Yep.
or attempt to derive any probability without a little bit more um, like feature understanding, if you will. You can do some labeling, and so like we could assign like weights to these features to
Yep.
say, well, like count of acceptances maybe matters, like maybe factors in arbitrarily like 10% into a rider's decision. So you could take like a weighted sum approach to label some of these people.
Yep.
Um, but again, there's pros and cons, but as a quick and dirty approach, I think it could work.
Yeah.
It could solve our initial like hypothesis about which features like contribute most to the driver's propensity to accept or reject a rider
Mm-hmm.
request. And then from there, we could like evolve both in parallel. So you can always fine tune the ground truth value and the label that you're using, and then build a deeper understanding of the data. And then you could actually this product experiments. So this is the next kind of angle that I would want to look at it with, is like if we were to conduct a couple of A/B tests and look at drivers, and if we showed certain portions or certain pieces of information to them, is it like, let's say we identify, hey, distance to destination seems to be a feature that matters a lot. So if we show that, how does it influence the driver's decision in
Yep.
this control group and test group? This would actually start a chain reaction of experiments, essentially. The model itself would just be like a part of, I think it's like a means to an end to understand the data.
Gotcha. Okay. So there could be potentially, different amounts of information that pop up with different models, and then we'd have to run these experiments in some sort of controlled fashion.
Exactly.
Could you briefly describe like what the best way would be to like run that kind of experiment? Would we be like chaining these? Would we have like 10 different variants? I guess how would the rollout kind of go?
Yeah. Let me think about that a bit. So I think once you get, let's say, like a logistic regression up and running, you
Mm-hmm.
at that point kind of look back and say which of these features are contributing most. Okay, so let's say you identify, let's say like as a data scientist slash product analyst, I go back and say, oh, PM, I think we should run a test with showing distance to destination and time to drop off. So this is like, I mean, this is kind of interesting because in the first one, and this would be A/B tested, of course. So A, B, and then same thing here.
Mm-hmm.
But what you could do is you could use the results of distance and feed that into this second experiment. So, and I'll explain what that means.
Okay.
Well, group A of drivers was shown distance, and group B of drivers was not shown a distance. Okay, great. Now, let's see when they were shown a distance, how likely they were to accept. Okay, great. But now, my hypothesis there is that once you show a distance, the larger the distance, the less likely someone is to accept a ride request.
Okay.
It makes sense.
Yep.
But then all of a sudden, if you switch that, because what you're doing is you're putting the mental onus on the driver
Yep.
to figure out, well, you know what, even if it's like 100 kilometers and it'll take me an hour, it's better than me going 10 kilometers and going for 45 minutes.
Yep.
But the driver doesn't actually know that data, doesn't have that information given to them if they're just shown distance. Now, what would be interesting is like showing them time. So instead of giving you a distance, I say, okay, well, the this ride is going to take 5 minutes, 10 minutes, 15 minutes to complete.
Mm-hmm.
But from there, and then you would show that to the same group that you show, the same split, which you showed the distance distance metric to, the distance feature to. So you would use that same kind of like, you would have that same control and test group. Now from there, what would be really cool is to show them both, to show group A both distance and both time, and see what the effect there is. This way, you're kind of like really figuring out is like, what's that kind of mental calculation a driver is doing when they're choosing to accept or reject a ride. So my entire like roadmap of experiments would be trying to really discern the driver's like mental pattern by and like trying to figure out, okay, what is the driver really thinking and what factors are influencing their decision when they're making that when they're choosing to accept or reject a rider.
Mm-hmm.
And from there, I can figure out which riders are the best to position to which drivers based on their thinking patterns.
Gotcha. Okay. So
Yeah, yeah,
it would be almost like testing to figure out the optimal solution for the optimal driver, um, but not something that we obviously like roll out to the entire population, right? There's not one size fits all for this.
no.
Yeah.
It'd be hyper personalized, hyper targeted to a driver's uh, like honestly driving pattern.
Gotcha.
Because uh, and there's so many, and I'm sure Uber has done so many like cuts of this, that the type of drivers can range from this is my primary job to this is like a hobby that I like to do once in a while.
Mm-hmm.
And if you already have that incentive, then you can really start to dig into different driver profiles and say, well, for a person who treats this driving or Ubering as like the primary job, their behavior is likely going to be very different from a hobbyist. But how can I how can I present them with the best rider that optimizes their take home?
Gotcha. Okay.
Yeah. And the other features are all going to contribute to this, because likely someone who's kind of treating this as a full-time job, I'm willing to bet has two vehicles. One is like a throwaway and one is like a primary. And they're only going to take out the primary, be it like a minivan, if they have a real incentive to do so. Where if I kind of tell you up front, you're likely going to be picking up parties or riders of more than four
Mm-hmm.
for the rest of your like shift, and I know you're likely going to be taking a shift of like 4 hours because this is when you tend to go out, then it's super beneficial because I don't have to reject anybody at this point. Every ride that I pick up is going to give me an Excel bonus, and it's likely going to be short, and and I can figure out which riders I want to pick up because of certain neighborhoods or certain features that I'm going to kind of know and be given that information about. And it could be and I know I'm going kind of crazy right now, but it could be as like fun as presenting a pre-trip summary and a post-trip summary. So a pre-trip summary would be kind of giving you a lay of the land. Say, this is what your shift is going to look like for the next 4 or 5 hours.
Yep.
Post-trip would be, here's all the things that you've done. How can we make it better?
Yep.
And you start collecting that feedback about a driver as well. So it would start that flywheel.
Yep. Awesome. Yeah, I like that. And I think that it definitely has to encapsulate something bigger than just the initial, driver request problem, right? Because it ties into the rest of the ecosystem so seamlessly that, one change affects everything else.
Yeah. I'm hoping that the model is one piece in the domino.
Yeah. Yeah, I think that's right.
Yeah.
Cool. I'd love to take this time then to just do kind of a retrospective quickly on the interview question.
Mhm.
What do you think about the question itself? How do you think that, like, basically, what do you think Uber is trying to get out of asking like these types of interview questions almost? And then,
Mhm.
yeah, let's just start with that.
Yeah, I think so. More important, and I didn't talk about metrics in this interview, which I think I could have.
Mm-hmm.
But from a metrics angle, I think what Uber is trying to understand is, can you think holistically about our business, and not just through the lens of a model or the data that you have access to. It's like, can you connect what your efforts are to improving either the driver's experience, the rider's experience, our bottom line, things of that nature.
Yeah.
So thinking big, thinking holistically, and thinking deeply about the user and the product. And then letting that determine what to prioritize and what questions are worth solving as you're doing your data science work.
Yep. Okay. So would you say that, I guess in the beginning, just doing a lot of the clarification, doing a lot of the understanding of the business itself is probably the most helpful towards solving a question like this as well? Because I think
Mm-hmm.
like a general business intuition aspect of it, right? And then there's a machine learning kind of like knowledge aspect of it as well. When we're
Mm-hmm.
going through understanding like the trade-offs between things. Would you say that one outweighs maybe the other, or that they should just tie in like almost seamlessly together as you're thinking of modeling out this whole scenario while you're doing the question?
Yeah, I mean, the unicorn answer is have both and do them well and have 10 years of experience while doing both.
Yeah.
But unfortunately, I don't think that's the reality. So the way that I've answered that question for myself is to focus on your like on the strengths that you bring to the table. Um, Many times, data scientists, I think, or potential like people who are interested in the field, tend to focus very deeply on the technical understanding. And while that's important, if that's like not if that's something that you maybe don't naturally gravitate to, or that you kind of like spend a lot of your free time thinking about, or even in the back burner, that's okay. Because I think there's a lot of people out there that can do that job probably better than you can.
Yeah.
For me, it's kind of come down to, okay, well, I kind of thrive in understanding the product, the user, and the experience, and I want to make that better. So everything that I learn from a technical angle, I try to connect back to that and say, okay, well, if I'm doing this work or if I'm doing this task, how is it like impacting this bigger picture? And how am I impacting the end user's experience with the product? Um, and I think that's actually a pretty unique kind of perspective to have if you come in as a data scientist, because there's less of those. There's less product and data science thinkers. It's like a Venn diagram, right? You have a lot of product managers and you have a lot of data science people, and
Yep.
you have like a lot of software engineers. So what if you kind of position yourself at the nexus of all three, and you become a jack of all trades of all three, but have a deeper like a good technical foundation amongst all of those Venn diagrams.
Yep.
Not necessarily have to be a specialist in one or the other.
Yep. I like that. And I would say that that is the overlap is probably the percentage of people that have that like little overlap is very small. And I'd say that a lot of times the people that come in have this like uh, maybe they just like did a boot camp, or maybe they just did some sort of online course specialized in machine learning, and so their machine learning aspect of knowledge is very high, but it's not tied to that like product or business sense from maybe you get from industry, maybe you get from experience, or maybe that you just have to kind of I guess learn from thinking about it more. And that's probably the crux of what you see a lot of people getting rejected in interviews for, is that having that like not having that knowledge to kind of embellish that kind of like modeling part or machine learning kind of concept part.
Yeah. And I mean, as I kind of work with a couple organizations and through my program, like through a capstone project, I've realized that modeling and uh, the more technical aspects can be learned, because each company is so different. No matter how much you try to like find an overarching, like, yeah, this approach works, it's not necessarily going to work for every company. And that's kind of, I think, part and parcel. But what does seem to work for most companies is when you come in with an understanding of how to pull data for yourself, ask the right questions, and then get basically like accelerate your time to learn the domain with your understanding of data.
Mm-hmm.
Because you're going to be dealing with veterans in whatever industry you play in as a data scientist. That's why you're like kind of coming in, because that domain specialist doesn't have the kind of technical or the data understanding that you do as a data scientist. So your value really is really like being able to learn their business faster than they ever could in the past because of all this new technical knowledge that you've gained. But
Yeah.
if you don't demonstrate that, or if you don't want to, like, if you're not keen to actually, invest time into learning all the nuances about telematics or all the nuances about healthcare and the nitty gritty things, then it's kind of a turnoff, because the data is only going to give you a slice of the story. It's going to get you there faster, but it's not the whole thing. So, and people tend to like put their domain experience on the back burner and say, oh, well, I've already done that and I know that and I don't need to say it again. But I think it can be one of your most biggest assets if presented correctly.
Yeah.
Um, and like a great example of that is actually just even knowing what certain features in the data set mean. If I'm a data scientist going into a networking domain and I have a little bit of background in networking, I'm so much better than a general data scientist who has no idea about that
Yeah, I agree. Awesome. I think that wraps it up for me. Chinmay, do you have any last comments?
No, it's been a lot of fun. I mean, I think taking a mock interview or taking an interview like this is actually itself like an interview. It really needs to be treated like kind of seriously. And I wish I had more prep time, but unfortunately, like I'm just kind of all over the place and scattered.
No, I think that's
But
good though.
yeah,
Yeah.
go ahead.
No, I think it was good. I think you explaining your thoughts is also probably one of the prime things that maybe doesn't happen in traditional interviews as much, but it's great for understanding in our context as well. Like,
Yeah.
I'm sure there's more of a summary that happens in regular interviews to account for time and the interviewers patience, along as a myriad of other factors as well. But
Mm-hmm.
awesome. I
Yeah.
think that's great. I will talk to you later.
Thanks, Jay.